Hi, in this video I am covering signal processing engineer related work roles and the areas in which Unistring Tech Solutions is working. The main goal of this video is to highlight the key applications in which the signal processing engineers, talented signal processing engineers who wishes to work on algorithms and who want to apply all the signal processing concepts that they study in the undergraduate and postgraduate courses, how Unistring can be a good platform where you can pursue your internships and followed by full-time jobs and contribute to the overall national growth while developing the defense applications at Unistring. Unistring is established in year 2007, and I would probably skip in this presentation. There will be separate videos which talk about the company profile and all. So we are a combination of R&D and production capable company. So this is the directed team of the company. And in the recent past, Unistring is actively working with DRDO and Indian Air Force, Army, and building counter-drone applications. So more about this you will see in our corporate video introduction of the company. So I request you to browse that video and get more insight of what we do. So today Unistring is focusing mostly onto the drone and anti-drone related products. So we build drone based certain payloads related to RF technologies and all. So that will be used by our armed forces, and we build anti-drone systems by which if the drone attack is from the other enemy side and all, how to address that. So this is a view graph of typical our anti-drone system, and we also build big size drones which can catch using nets with the small size drones. So more about this also you will get in our corporate video. So this is one of the, so as I said, this particular video is more to give insight of the signal processing algorithm. So this is one of the patented product in which we build radar decoy related kind of waveforms. So like we want to confuse the radar. So then this is a product. So this is already patent is granted for this, and you can see that the drone is a big size drone. It is with roughly 1 meter wingspan, and it can take a payload. The payload that you see here is this. So we build algorithms related to radar, target, jammer, this kind of algorithms into that, and this flies in the air in front of the adversary radars, enemy radars, and confuses with the false targets and all. Now coming to another interesting area where the signal processing achievement has been done tremendously, and there are patents in this for Unistring, that we use digital beamforming at the heart of our system, which is called electronic scanning. So we use multi-antenna systems. The image shows there are around 42 antennas are there, and we use all of them to scan the beams, the detection beams. So underlying this technology of digital beamforming, so we have done a lot of things in digital beamforming. We have done world-class synchronization techniques for digital beamforming, which is like hardware software invention. We have done null steering, like you want to have a jammer, and with the digital beamforming you want to put adaptive null towards that. So we implemented that. So and we use digital beamforming in all our products, and we have supplied the digital beamforming solutions to Bharat Electronics, DRDO labs, which are on the third party hardware, but the key algorithm of digital beamforming supplied by us. So this is one potential area where the signal processing guys have done tremendous achievement, but there's a lot to do, and we look for talented freshers and talented students to join our company in this area and build world-class products with the digital beamforming. Now this is also about some of the key achievements. I'll skip this in the presentation. Now look at it. See, as a company, because Unistring is a product development company, so we develop the end-to-end product right from antenna to the final display, in which the army operator directly sees and takes a decision, presses one button, and the gun directly fires or the missile fires onto that. So since it's our product development company, all that you studied in the digital signal processing in some form will be used in some of our stage of the software development. Like our digital signal processing guys, They are the guys who sit along with the hardware guys and they talk about the link budget analysis, RF path loss, antenna gain. So indirectly all your analog electronics related, like you talk about the amplifier gain, distortions and all, the model, and the digital signal processing team will take part very active role in signing the hardware architecture, in saying that this works. So analog electronics and even the analog design, right from antenna, path loss and all that, the digital signal processing guys plays role. Next, I am going to show in the subsequent slides, our main capability is FPGA based digital signal processing. So the FPGA coding guys will closely work with the C programming guys, like the signal processing guys and all, who model that. So I'll talk more about the digital electronics. Now coming to next is the decision theory. So I talk about multiple things, like if it is an RF detection, if drone is emitting an RF, and if a wireless module is emitting an RF, the drone RF has got some unique signature. So classifying whether it is a drone or any Wi-Fi or Bluetooth, there we use a decision theory. Now radar. So in our radar applications, we get echo from the birds, echo from the drones. So there also we use the decision theory. So decision theory or classification is something which we use in all our products. Like we build image processing. So we use camera to detect for detecting and classifying whether the emission is a drone or it is actually a bird which is false detected by radar. Now the image processing, where we use a neural network and deep learning methods and neural networks, where we train the algorithm for that, is also a decision theory. So all these branches that you see in the digital signal processing, they are there in our company in different products and all. So our company gives a enormous opportunity for the guys who are interested in signal processing to learn what is being available, to study the literature, to innovate with a new algorithm, and can do a magical improvement in the system. Why do I call a magical? See, it is an algorithm and architecture which can decide the cost of the product, performance of the product and everything like. Rest of the hardware building team, software building team, they build as per the algorithm that is finalized. So algorithm and architecture becomes the first point which decides the success or failure of the company. And I'm proud to say our company is having very good signal processing division, and we look forward to take up more and more talented and enthusiastic students. See, I will tell you, it is the rarest skill that I see in the people. Like lot many people join in MTech and BTech, and where they say, sir, we want to do DSP and all, but very few people who actually understand the concepts. Like if you are the student who like this signal processing, who understood nicely this Fourier transform, cosine transforms, and you can visualize this FIR filter, IAR filter, what do you mean by impulse response, what do you mean by this eigen functions and all. I'm telling you, you are the guy who ideally should work only on digital signal processing, because there are hundreds and thousands of people who can work on software verification and all like that. So getting an intuitive liking towards the digital signal processing, I would say it is a natural gift. It's a God's gift. So you should stick to the core companies like us and work on digital signal processing only, because these kind of people, the algorithm developers and architects, are very rarely available in the current generation of students which are coming out. So keep like if you like it, then do a serious try joining a signal processing algorithm developer or architecture developer in any company like Unistring or any company which develops the products, end-to-end products. Now going to radar. So we build complete radars, end-to-end radars, rotation based radars, digital beamforming radars and all. So all the company developed products, end-to-end algorithms are developed in our company. So we work on multiple algorithms, monopulse tracking, range Doppler mapping, all that micro Doppler based algorithms and all. So I'll not go into details of all this. So this image is just to give you an an impression at different stages, different algorithmic blocks that are involved, right from waveform selection, correlation, getting the correct correlation gain with selecting the linear FM or non-linear FM, the advantage of the pulse compression, overcoming basically the clutter effects, overcoming and detecting the slow moving targets in the presence of strong clutter. All these are algorithmic challenges. We already done this. We are in the process of improving further to detect long range radars, long range drones and all with our radars. and micro Doppler is one of the important thing. Okay, before I go to that, we work on both the type of radars. We work on FMCW radars, we work on pulsed radars, we work on both the type of radars. So our algorithm team works on both the projects one after another like that. So then micro Doppler is very important thing. So we worked on W band radars like 81 gigahertz band radars and all. So we work on X band radars, S band radars and all. So when we train our models, our classification models, like a person walking, so when a person is walking, his hands will have a moving signature. So we train with our first we characterize that the moving signature, what type of Doppler, additional Doppler is creating on top of the bulk Doppler, and we train the model and we detect the person, the walking person, whatever is coming, is it a person or an animal like that. This is one of the product that we have done, and it is getting improved further. And we have worked on this micro Doppler detection of the drone blades. So when you have a multi-copter and it has got blades, and they have a separate micro Doppler signature. So we use that for classification. So these algorithms are also under final stage of testing and deployment, and we look forward to improve further, because see, signal processing is like an ocean. You have lot of algorithms, continuous inventions, and good thing is all these algorithms are well published and available in the literature as IEEE papers, transaction papers, IET papers, journal papers and all. Reading, understanding, conceptualizing them, first working initially with the C or some initial tools like MATLAB or Octave like that, then guiding the VLSI guys in FPGA, guiding the embedded software guys to write C code and all. This becomes a starting point which we call as conceptualizing the product. So every product in our company is initially conceptualized by signal processing team only. Okay, now next thing, as I told, signal processing team has got a tremendous role in hand holding the FPGA guys in design, architecture, even verification and validation. Like what our team will do, we use Xilinx FPGA. So in Xilinx FPGAs, you have the FFT core, FIR filter, you have BRAMs, their latencies, their performance, their bit accuracy, their cycle accuracy, all of them need to be modeled initially by signal processing people only. So if our FPGA guys are innovating constantly and they are able to produce very effective output, it is always backed up by our signal processing team. Then this is another view graph that is showing in a typical FPGA architecture how the FFT multipliers, their bit accuracies, their latencies, Cordic kind of algorithm, Cordic algorithm, their bit truncation effects, all that is modeled by our signal processing people. If you are an algorithmic lover, you love to work on this kind of blocks, then Unistring is the correct place for you. And again, the FIR filters. We have done a lot of innovations in FIR filters. On top of what Xilinx gives FIR IP core, because all our signal processing blocks, they talk about multi-channel processing, 8 channel, 16 channel, 32 channel, 64 channel. We call that as a massive beamforming architectures. So we innovate with the FIR filter tight optimization, utilizing the Xilinx high-speed blocks, and in a small FPGAs, because cost is very important. Because if you keep putting higher and higher FPGAs, higher capacity, it's heat dissipation is a challenge, and because of increased cost, winning tenders with the global tenders, open tenders from Indian Armed Forces is a challenge. So we innovate at the architecture level so that we tightly pack our algorithm with a small size FPGAs, and that's how we get a cutting edge products. Okay, again, something related to what we have done with the polyphase FIR filter. So we have a proprietary blocks in our company. So we talk about the models. So those things we use in our modeling and also on FPGA implementation for all the 3 category: high pass, low pass, band pass, and band stop, all these filters. Now, so I asked my corporate training team, to keep one slide to show in depth of how we model about this one. See, usually when we talk about the college level academics and all, we talk about this direct digital synthesis or numerically controlled oscillator. But when you are building a product, there are a lot of places that you have to take care. For example, this is what is called digital frequency word. So you give digital frequency word, then the phase accumulator accumulates that and gives the digital phase, and digital phase is given to the lookup table which converts the phase to amplitude. Then you get you start getting what is that called the amplitude words, nothing but the digital numbers which will be given to digital to analog converter. You get a sine wave. Now you see, if you look at what level of involvement that the signal processing guys need to do in this kind of product building. First of all, the digital phase accuracy decides your whatever the spurious that you get, the frequency words and the phase words that you generate. So here you employ something called phase dithering, where you intentionally add random noise at the phase level so that you control the spurious. So always there is a spec that we take. Usually we talk about 80 dB spurious free dynamic processing in digital. So we have to control that. So you have to have something called phase dithering over here. Then this frequency word has got so many linkages with RF, IF and all, because see, digital is only one part. You have a digital, you have a PLL external outside, you have down converters, you have up converters. So all of them will take the clock from one reference clock word. So even the FPGA gets a reference clock. So it is very important that you should not have any round off effects in your frequency word, because the frequency word here, the F naught is equal to Fs divided by 2 power n. So if n is nothing but your whatever the width of that, you have a finite resolution. But the products like radars and all like that, even 100 Hz error will come as a wrong Doppler frequency. So not even 1 Hz is not allowed. In the system of a radar like transmit receive system, both must be synchronized and you must prove 0 Hz error. To prove 0 Hz error, what you are supposed to do, in conjunction with your RF, IF and other stages, without introducing any round off errors, you must choose carefully your frequency word in your DDS. That is because you have a finite number. When you take 32 bit, you will still get 4 Hz, 5 Hz error for a 100 MHz clock if you calculate like that. So signal processing team plays enormous role in deciding every finite spec in the digital, and tell the FPGA guys, you select this, you code like this and all that. And this is what I will call, in Unistring you have a dedicated training program. Once you join as an intern or a fresher, you will undergo a tremendous training program where all your subject concepts with industry relevance are bridged and you are trained onto that. In fact, while my guys are publishing this kind of video to you, they would have already published some self-paced learning kind of online available, either Unistring videos or some expert lectures which are very important concepts. So you can go through them and you can actually complete those courses, then appear for Unistring technical interview and all, where the chances of your selection will go very high. Okay, now this is a more detailed explanation of the digital down converter, so whatever I have shown previously, the block diagram, when it comes to FPGA implementation, more important effects of that, how they become role, this one. So another point I want to highlight, the signal processing people who know how to do validation, they are the guys who are finally the acceptance, like the final ATP or final STP, software test plan and software test reviews and all. They are the guys who do both for FPGAs and software, embedded software guys. Okay, now I am moving on to another application. This is ELINT, which is called radar electronic warfare. There are multiple shortcuts to it. ELINT, they call ESM. These are all military words. Don't worry much, but broadly what is that? See, you know that our enemy will use basically radar as a basic tool for detecting this one. So we don't want to actually detect it by their radars. So we will learn their radars. Then finally we coin strategies to jam their radars. So learning out of their radars, extracting the parameters of the radars is nothing but called ESM, electronic support measures, or electronic intelligence called ELINT. So what is the challenge here is, because you don't know in which frequency they are coming and which pulse width, which PRA you are coming. So the challenge here is your receiver will get combination of all of them. When you get combination of all of them, you will use some statistical methods, some neural network kind of training methods to separate them out. So I want to highlight what kind of algorithms we work. These are already working algorithms, deployed systems, but we are looking, because there is no end. As I mentioned, you keep innovating and all. So what we do, we use multiple parameters of the radars. We use frequency, we use pulse widths, we use PRAs, and we have what is called classification, multi-dimensional classification techniques, where we give weights to each one, like frequency weight, pulse width wise weight, PRA wise weight, time of arrival weight and all. Using these weights, we classify the incoming pulse train. Like the incoming pulse train, as you can see in this diagram, is a combination of multiple radars. then we separate them out. So this is what basically the clustering algorithms that we use. So I'll not go into more details. So these are kind of algorithms, people who love the statistical methods, people who love this, what is that called, this is called n-dimensional clustering algorithms, so we use all of them in this, and we use also neural networks, but neural networks, like, they take time, and these only neural networks we use as a beginning for the training, but once the training is done, then we use only n-dimensional clustering algorithms only we use. So these are the more insights of the pulsed interleaving algorithm, and we possess more than a decade experience working in this kind of algorithms, and we use these algorithms to detect even modern radars with a multiple level of staggered PRS and all like that. Now, next I am moving to another one topic to highlight different signal processing areas we work. See, in our products, we using our EW techniques, not only separating the radars, communication receivers, we also precisely tell where it is in the 3D map. Okay, we compute the coordinates. Now this is a very powerful thing, because if our troops know where is our exactly where is the enemy radar, where is the enemy radio sets, where is the enemy base station, mobile base station, or other things, by launching some missiles, by launching something, they can destroy them. The moment if electronics is destroyed, then there is blind, and this is what actually the heart of what is electronic warfare. So electronic warfare is use all electromagnetic techniques, and you try to identify where they are, where the radars are there. If they are moving, you indicate on map also they are moving like that. So our company works both on the air defense, that is detecting the drones, detecting the UAVs and giving onto the air defense systems. Also works on basically ground based ELINT, means our system will be on drone and we will be mapping on ground where the radars are there, where troops are there. So we have both the kind of products. As I mentioned, we detect enemy drones, that is called our counter drone product, and we destroy them, and we have a drone based system to detect the enemy ground locations and all like that. So here we are building lot of algorithms in on FPGA real time for angle of arrival based location fixing, time difference based location fixing. For people you don't know much, don't worry much, you can simply think they are similar to your GPS, whatever the techniques in which the GPS works. Like it's called triangle, what is it called, time difference of arrival, time of arrival techniques. So we have synchronous receivers, two drones which are synchronous, their own synchronization is there. They receive signals at the same time, nanosecond level accuracy. Then we use cross correlation algorithms. We estimate the time delay, and time delay maps to hyperbolic curve. Multiple stations means multiple hyperbolic curves, and all these hyperbolas intersect at one place. That is the location of the signal source. So this is quite similar to what in GPS, how the GPS uses technique like that. Then one more technique is called triangulation. Like each sensor independently estimates the lines of bearing. So I have a line of bearing here. Lines of bearing means direction of arrival. So I have one drone which is telling my enemy signal is coming from this direction. Where is, I don't know the location. After 10 kilometers I have one more drone which is telling this is a line. So all these lines of bearing will intersect at one place. So this is called triangulation technique. So in our products we put both of them. So because each technique has one method. Okay, so thank you for your time. So this message is intended to reach students who keep interested working in the core technologies, electronics, communication, electronic instrument students and all. Also to professors who would encourage the students to pursue career in the core technology areas, because most of the students, most of the professors think there are no companies to work, product building companies in core technology area, but Unistring is one of them, and we have multiple openings. So based on your current requirement as a fresher, as an experienced, or as a for internship, so I request you to join Unistring, work with us, and we are working for a noble cause, strengthening our armed forces with electronic warfare. And if you are a signal processing lover, probably you are the one who will conceptualize a new product, new invention, new patent, and give cutting edge solutions to Unistring and also to the nation. Thank you.